NEC Article 110.26 mandates adequate working space around electrical equipment to ensure safe operation and maintenance. This article focuses on the interpretation and application of this code to motor control center, or MCC installation. Table 110.26 specifies minimum clear distances for equipment operating at 600 volts or less to ground that is likely to require examination, adjustment, servicing, or maintenance while energized. When evaluating an MCC installation for compliance, several factors must be considered. Firstly, assess whether the MCC is likely to require examination, adjustment, servicing, or maintenance while energized. If the MCC contains live parts that must be accessed for troubleshooting or repair, or if it is part of a critical system where downtime is unacceptable, then it is more likely to fall into this category. Secondly, consider the presence of safety features such as interlocks that prevent access to live parts while energized. If the MCC has sufficient interlocks, it may not be considered as likely to require energized work. Thirdly, evaluate whether there are alternative means to monitor or diagnose problems without accessing live parts. For example, permanently installed ammeters or remote monitoring systems can reduce the need for energized work. In a specific case where less than half of the MCC is across from a metal bulkhead that is 38.58 inches away, which is less than the 42 inches typically required by Table 110.26, a detailed analysis is necessary. In this scenario, consider the following points. Firstly, the connections of the MCC are accessible, but only for taking amp readings while energized. Secondly, there is an ammeter on the front of each MCC can. Given these conditions, it is possible to argue that the reduced working space is acceptable if access to live parts while energized is prevented by interlocks and ammeter readings can be taken remotely using the ammeters on the front of the MCC cans. However, it is essential to conduct a thorough risk assessment to determine whether the reduced working space complies with NEC Article 110.26. This assessment should consider the specific characteristics of the MCC, the likelihood of energized work being necessary, and the presence of safety features and remote monitoring capabilities. Ultimately, the determination of compliance is based on a balanced consideration of these factors. It is reasonable to argue that the reduced working space is acceptable due to the safety features and remote monitoring capabilities of the MCC, if the MCC is inspected and maintained regularly to verify that these features are functioning properly. Key considerations include the voltage to ground, the presence of exposed live parts, and the likelihood of needing to perform maintenance while the equipment is energized. The table specifies minimum clear distances based on voltage and the conditions present on the opposite side of the working space. Condition 1 is where there is exposed live parts on one side and grounded parts on the other side of the working space, or exposed live parts on both sides with a grounded center. Condition 2 is where there are exposed live parts on one side and insulated parts on the other side of the working space. Condition 3 is where there are exposed live parts on both sides of the working space. If the voltage to ground is between 0 and 150 volts, the minimum clear distance is 3 feet for all three conditions. If the voltage to ground is between 151 and 600 volts, the minimum clear distance is 3 feet for condition 1, 3.5 feet for condition 2, and 4 feet for condition 3. To determine the appropriate working space, firstly, identify the nominal voltage to ground of the electrical equipment. This is the voltage between any live conductor and ground. Secondly, assess the conditions present on the opposite side of the working space. This will determine whether condition 1, 2, or 3 applies. Thirdly, using Table 110.26, find the minimum clear distance based on the voltage and condition. It is important to note that these are minimum requirements, and additional working space may be necessary for safe and effective work practices. In situations where the required working space cannot be achieved due to physical constraints, it may be possible to use alternative methods to ensure safety. For example, using insulated tools and personal protective equipment to energizing the equipment before working on it, or implementing a documented safe work procedure. Any alternative method should be carefully evaluated and approved by a qualified electrical professional. When evaluating MCC, it's crucial to consider their specific design and function. MCC often contain numerous individual motor starters and control components, and the accessibility of these components can vary. If the MCC is designed with barriers or interlocks that prevent access to energized parts, the required working space may be reduced. However, if the components are easily accessible and likely to require frequent maintenance, the full working space requirement should be followed. It is also important to consider the potential for future modifications or additions to the MCC. If there is a possibility that the MCC will be expanded or reconfigured in the future, it is best to provide adequate working space to accommodate these changes. Regular inspections and maintenance are essential to ensure that electrical equipment continues to meet safety standards. During these inspections, the working space around the equipment should be checked to ensure that it is free of obstructions and meets the requirements of NEC Article 110.26. Any deficiencies should be corrected promptly. The interpretation and application of NEC Article 110.26 can sometimes be complex, and it is always best to consult with a qualified electrical professional if you have any questions or concerns. These professionals have the knowledge and experience to assess the specific circumstances of your installation and provide guidance on how to comply with the code. This article provides a general overview of the requirements of NEC Article 110.26 and how they apply to NCC installations. However, it is not a substitute for reading and understanding the full text of the code. It is always best to consult the latest edition of the NEC and to seek guidance from a qualified electrical professional to ensure that your electrical installations are safe and compliant. Additionally, consider any local amendments or interpretations of the NEC that may apply in your jurisdiction. Local authorities may have specific requirements that are more stringent than the national code. Always check with your local electrical inspector to ensure that your installation meets all applicable requirements. In summary, NEC Article 110.26 is a critical safety requirement that must be carefully considered when installing and maintaining electrical equipment. By providing adequate working space, you can help to protect workers from electrical hazards and ensure the safe and reliable operation of your electrical systems. Always consult with qualified professionals and follow all applicable codes and standards to ensure the safety of your electrical installations. To elaborate on the risk assessment process, consider the following steps. Firstly, identify all potential hazards associated with working on the MCC while energized. This includes the risk of electric shock, arc flash, and other electrical injuries. Secondly, assess the likelihood of each hazard occurring. This will depend on factors such as the frequency of maintenance, the complexity of the tasks, and the training and experience of the workers. Thirdly, evaluate the severity of the potential injuries. This will depend on factors such as the voltage level, the available fault current, and the type of protective equipment used. Fourthly, determine the overall risk level by combining the likelihood and severity of each hazard. This can be done using a risk matrix or other risk assessment tool. Fifthly, implement appropriate risk control measures to reduce the risk to an acceptable level. This may include eliminating the hazard, substituting a less hazardous alternative, engineering controls, administrative controls, and personal protective equipment. Sixthly, regularly review and update the risk assessment to ensure that it remains accurate and effective. As conditions change, such as new equipment being installed or new maintenance procedures being implemented, the risk assessment should be updated to reflect these changes. In addition to the specific requirements of NEC Article 110.26, it is also important to consider other relevant safety standards and best practices. These may include OSHA regulations, an FPA 70E standard for electrical safety in the workplace, and industry-specific guidelines. These standards provide additional guidance on how to protect workers from electrical hazards and ensure a safe working environment. Engineering controls are measures that are designed to eliminate or reduce the hazard at the source. Examples of engineering controls for MCC include interlocks, barriers, and remote monitoring systems. Interlocks prevent access to energized parts while the equipment is in operation. Barriers physically separate workers from energized parts. Remote monitoring systems allow workers to monitor the equipment without having to enter the working space. Administrative controls are procedures and policies that are designed to reduce the risk of electrical injuries. Examples of administrative controls include lockout-tagout procedures, safe work permits, and training programs. Lockout-tagout procedures ensure that equipment is energized before any maintenance or repair work is performed. Safe work permits require workers to assess the hazards and implement appropriate safety measures before starting work. Training programs provide workers with the knowledge and skills they need to work safely around electrical equipment. Personal protective equipment, or PPE, is equipment that is worn by workers to protect them from electrical hazards. Examples of PPE include insulated gloves, safety glasses, and arc flash suits. PPE should be selected based on the specific hazards present and should be properly maintained and used. Regular training is essential to ensure that workers understand the hazards associated with electrical work and how to protect themselves. Training should cover topics such as electrical safety principles, hazard identification, risk assessment, and the proper use of PPE. Workers should also be trained on the specific procedures for working on MCC and other electrical equipment. A comprehensive electrical safety program should include all of the elements discussed above, including engineering controls, administrative controls, PPE, and training. The program should be documented and regularly reviewed and updated to ensure that it remains effective. By implementing a comprehensive electrical safety program, you can significantly reduce the risk of electrical injuries and ensure a safe working environment for your employees. Always prioritize safety and consult with qualified professionals to ensure that your electrical installations and practices meet all applicable codes and standards. Remember that electrical safety is an ongoing process that requires constant vigilance and attention to detail. By staying informed and following best practices, you can help to prevent electrical accidents and protect the lives of workers.